So actually, it's another talk about modules. So I'm working here for PSI. I'm a member of a scientific group in PSI. And just the outline of the talk, I will skip it, so we start with the motivation. Actually, here there's a picture. The picture itself is not really important, but as a member of the scientific computing group at PSI, I work for the AMAS group, Advanced Modeling and Simulations. And actually, this is just one of the simulations we are running. And this is for the commissioning of the Gantry 3. It's a beamline for our proton therapy center, a new one. And we just support the commissioning of this system with our simulations. Actually, this was the reason I started all this, because I was not really happy with the existing system we had. It was based on tickle environment modules, and we had a lot of problems because we need several packages like Trilinus, Boost, VTK, Root, Parmetis, of course, MPI. We are using several compilers like GCC, Intel, several versions. And usually the versions or the variants which we need, for example, HDF5 compiled with this GCC was not available. So actually, what we did, we compiled everything ourselves. So actually, we were not able to use the existing module system, or only parts of it. And then one big challenge actually we have is we have users worldwide. And it was always quite hard for them to compile all these packages. So we start to build binary packages. And actually, my goal was to provide a module system which can be used to provide these packages. And these packages are running on Mac, on several Linux systems, and yeah, are really used worldwide now. Okay. One problem I already mentioned, this was the missing compiler and MPI library combinations. Another problem was actually it was just too complicated to get this module. So actually I had to go to Valeri, ask him, can you please make this and that? Actually he tells me, okay, compile it on the system, and then I will build the module and make the module available. But actually, for me it was faster just to build the module myself or compile the package myself, provide it to our group, and that's it. Another problem was inconsistencies in just naming of shell variables. So you never know, okay, what's the prefix of the installation? Is it named like this? It's something like name home, name dir, or whatever. So actually we always have to check. And another problem is actually the system was only available for our PSI Linux distribution. But we have users using Ubuntu, OpenSUSE, Mac. Myself, I'm a Mac user. And there was nothing available for these systems. Okay, so what do we need? Actually, we need, of course, something which is compatible to the old environment module system, the tickle implementation. It should or must be usable on other Linux distributions because we have more and more users coming with their own device or just setting up an Ubuntu system. And then it must be very easy to install it on their Ubuntu system and must be usable. Of course, it must be available on Mac. The installation should be easy. And then some quite important thing was the idea to delegate the responsibility for a module. So we have some users, for example, users who always want the newest and greatest root version. And why not just giving them the possibility to build these modules themselves? Actually, this helps us because we don't have to take care for these modules, and the users are quite happy because they can build the modules themselves. Another problem is, this is actually a real problem, also for phasing out the old module system. Actually, we have some quite important system in the control room controlling our accelerators, and there they really don't know which modules are used. So actually, we cannot remove anything. Of course, this was already mentioned. We need something like reproducible builds. This is really something very important. So we really must be able to recompile the same software again and again. And another thing, actually, this was something I was always very unhappy with. We have a huge flexibility in this module system, but actually there are no rules. So I don't know which shell variables are set. Usually the path, of course, but what else? So actually, we do not support all kinds of CPUs. Actually, we only support some optimized modules for HPC system, then just generic versions for Linux system. Actually, we just support 64-bit system. 32 is nobody actually. There are only very few users still on 32-bit systems, so we only have to support this. And actually, this is also quite important. Many users are coming with a laptop like me, and I want to run the modules on my system. Okay. Actually, what I started was just to extending or write extensions to the Tcl environment modules. This is something like a module lifecycle. I will tell later about all these points. Something like module groups, module hierarchies. We heard already about something. Actually, this is, for me, the main feature of Lmod. And this actually we built into the Tcl environment module system, setting just defaults for some shell variables, and something more to get some useful help information, just to standardize something like, I want to know who the module maintainer is. Quite important, actually. So this is based on the modules, the current version. There's a wrapper script for the module command. Actually, this should be rewritten in the C or in the pure Tcl, just to make it faster. There's a Tcl library, which will be autoloaded. And actually, this was quite a huge problem for it. If you want to run it on Linux and Mac, you always have some tools you need which are not really identical. So very simple things like read link is different on Mac and Linux. Actually, yeah, why not Lmod? Yeah, actually, it's more, we are used to the Tcl modules. Maybe one of the main reasons is just I know Tcl quite well, but I'm completely new to Lmod. So, and actually, we do not see the really big advantages for us. Of course, there are a lot of advantages of using Lmod. Maybe if you really start from scratch with something else, I would use Lmod too. But for us, Lmod, we discuss it, but actually we decide against Lmod. Okay, let's start with the first extension. It's something like a module lifecycle. So actually, we need something, a procedure to phase out, to remove old modules. This I mentioned, we have modules used in the control systems, and actually they really don't know. I asked them, don't know. Okay, it takes quite some time to find this out. Okay, there's no support for this neither in a Tcl environment module, it's not in Lmod. So actually we have to implement something like this. So, we have a similar problem for new modules. Actually, we just compile something and we install them actually directly on the file system, and actually they're already or they are immediately accessible to the users. But we want to tell the users, be careful, this is just something new, this is unstable. You can use it, but use it on your own risk. So actually, we tag these modules with a release, and actually we have just 3 releases. This is unstable, stable, deprecated. So unstable, yeah. Be careful, stable is production ready, deprecated. Actually, just we have a way to tell the user, stop using it. So they cannot complain if we remove it one day. And we can also add a note when we are going to remove it, so that really the user gets some information. This module will be removed then and then. So this can be done just by the user. Actually, by default, only the stable modules are visible to the user, but if the user decides that he wants to use unstable or deprecated modules, he really has to do something like this, add this to the bash profile or whatever, and then he see all the modules, even the unstable and the deprecated ones. Okay, another thing which is, as far as I know, also not available in the Lmods is something like grouping modules. Actually, the idea behind grouping modules is that we have some modules which we do not want to expose or just do not show to the normal user. Actually, these are tools like benchmarking file systems, something like Unison. Users usually don't need. And just to be able to hide this module in an easy way. You can do it with a module path, but you don't really have to know what the module path is and all this. So some groups are just something like programming tool system, libraries, and actually this system and libraries are usually hidden. Libraries I need, for example, to compile other modules, for example, the MPC or MPFR for compiling GCC. They are usually of no need to the users, but we want to have them as a module. So the users can just, if the users want to add, want to use some of these modules, he can just say, okay, module use system or module unuse something. So actually, this is just a short output of a module avail command. So you have this groups tools, or the default groups tools and programming. And actually, this is just not complete list of everything. And here, what you see here is, for example, this marks a module as unstable. And here we have something like a deprecated module. So here we have a new GCC available, and this actually should not be used anymore because we have 4.8 GCC, a newer 4.8 GCC already available. Next are the module hierarchies. Actually, you'd already told something about it. And yeah, the idea is really, usually you want to work with some tool chain, for example, for GCC 492 or whatever. And then you want to use, of course, the libraries compiled with this compiler. In a flat hierarchy, actually, you see all of them, even if it makes absolutely no sense to you. If you have a lot of this variance here, for example, here we support something like HDF5. If I compile HDF5 with 4 compilers and 3 MPI implementations, I have a list of like this just for HDF5 modules. And this is actually really confusing for the users. Is this module really available? You have to start something like grep, and then, okay, they don't know that the output is redirected to std error, not std out, and all these problems we are running into. Okay. So actually, we have some groups. For example, okay, all libraries or tools which are compiled with a certain compiler are going into the group compiler. Then we have, of course, combinations, compiler MPI. These are going into the group MPI. And then we have the group, for example, the group, we have compiler MPI HDF5. And these are going to the group HDF5. And here you can imagine that this can really grow fast if you really have to provide this in different combinations. Okay, if you want to load, actually, for example, an MPI module, you first have to load the compiler you want to use. For example, here we have an output of that. You have to load the module avail. You see or we saw already before we load the GCC. So here we load GCC 492, run module available just to get the list of available modules. Here we see which modules are available for the GCC 492. And here we have, for example, OpenMPI 184, and then we can load the module.
Do you provide any mechanism so people can search for modules down in the tree?
Not yet.
Yeah,
Lmod supports it, yeah, I know.
You have to teach them,
Yeah,
this is here, and then here, and then here.
Yeah.
And
What we have something, maybe I misunderstood you. We have something, this will be one of the next, this is already the next slide. We have a searching thing. So the spider, we have something like the spider in Lmod.
Lmod has a spider.
Yeah, so we have something similar. But what we do not have is the swapping mechanism. This we don't have.
Yeah.
This we want to implement. But actually this is more nice to have for our users. Okay, so of course this is a problem, maybe he already mentioned. So you don't know which module is available, of course, just by running the module avail command. So of course you want to know which HDF5 variants are available, which compiler are used and MPI implementations. And for this, actually, we have this module search command. And it's, in the simple case, it's quite similar to the module avail command from the Tickle modules. You just actually can specify, for example, OpenMPI, module search OpenMPI. Then you will get a huge list of all variants we have. Or you can restrict the search to something like this. So you can specify with GCC 492. Or if you want to search an HDF5 module, you can also specify with GCC blah, 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 with OpenMPI or with MPI-ch blah, blah, blah. So this makes it very convenient to the users to find modules and to search and to get an idea which modules are installed. So next are defaults for shell variables. So I already mentioned, actually there are no rules. Actually the module file itself may, or the writer of the module file can do whatever he wants. And actually you don't know, maybe if you load OpenMPI, is this set or not? But usually configure or CMake uses one of these prefixes, expected, some common prefixes, but I don't know whether they're set. Is a man path set, or is something like a C include path set? Don't know. So what we are doing for our modules is actually just set by default this or reasonable values for this. And some more we will see later. And if you don't like it, the module maintainer can override this. So there's no problem. So actually, so the prefix, we have something like here, OpenMPI, OpenMPI home, OpenMPI prefix. These are all three set. The reason to set all this is just, yeah, some configure scripts are using this, others are using this, and the next is using another version, something else. Also, same as for CMake. And actually, the main trick to be able to do this is we can derive the installation prefix just from the module path itself, so the directory where the module file is installed. So what we said else, path, of course, man path, actually no problem. We also said something like C include path, C plus include path, if this directory exists. Same for library paths and LD library paths. The advantage of this is actually usually you can run something like CMake configure without specifying anything. So you don't have to specify something like with HDF5 something, with MPI something. Actually, this works quite well for almost all of our software. Actually, this solves a lot of problems users have because most users have no idea how to run configure or cmake. But with this, usually just running cmake or configure is enough. So one other advantage of this is we can write quite generic module files because we don't have to specify all this, or we don't have to code this in the module files anymore. And we can really use the same module file, for example, for all versions of GCC, for all versions of OpenMPI. It's really the same module file. There are no changes. So this is something we need to support the hierarchical structure of the module files. Actually, we have to write some information in the module file, for example, for compilers, that the module path must be extended. This is not done like in Lmod, so we have to really code something like this in the module file. But it's just one line, for example, in the compiler module for module add group compiler, and that's it. Actually, it's just extending the module path. There's some simple but useful beautifier for the module help. Actually, just one proposal just to get some standardized output. Usually, users, maybe new users, just want to know the URL of the software. This is actually, from my opinion, quite important that the user knows something about the license. And of course, who is the maintainer? So who can I write an email? Who can I call if I have a problem? This is just an example of a module file for OpenMPI. So you see, this is quite generic. So actually, there are no specific things for the version, for the prefix, or something else. It's really generic. This can be used for almost all MPI or OpenMPI versions we have. Okay, so how do we distribute all this? So we are running AFS. AFS is available on really on almost all systems. And of course, this is not something which is restricted to AFS. You can replace AFS, of course, with some other things. You can also use it auto-mount or whatever. But actually, AFS, if you know how to handle it, it's quite convenient to use AFS for it. The installation actually is really extremely simple. And it's just setting something like a symbolic link to a directory in AFS. Okay, we come later to a short note about this. Add this. And okay, you have to source something, and that's it. This is just a short explanation. Something coming from AFS. So it expands to something like this. For a desktop system, actually, this is Scientific Linux PSI 6, but this can also be used, of course, for Red Hat clones. The modules are working also on 7. We are, now coming with more and more Red Hat or Scientific Linux or CentOS 7 systems. This works for Ubuntu and newer, for OpenSUSE 12 and newer. And then we have the directory for Mac. The modules are compiled actually on 10.9, but they're also running on 10.10. And here the last one are the modules which are optimized for the HPC cluster. So there was another request from users, of course, for example, from laptop users, or also from users, for example, from the beamlines. They want to be independent from AFS, from the network file system. They want to install the modules they want to use locally. And this is something we support. So for the time being, you still need some temporary AFS access. Then you can initialize a minimal environment module system with this command. So actually there's a new command like mod manage available in it, and then you have to specify some local directory. And you have to set the same symbolic link or the similar symbolic link. And of course, we need to source this file. And then you can install a subset, or actually module, just by running this command. Mod manage install module for all modules you need. Or there's a n-cursor-based dialog, really just displaying everything we have. A little bit structured, so that we didn't have a list of 200 or 400 lines, where you can select the modules you want to install locally. This is, of course, very useful for laptops, and yeah, here I mentioned it for some mission-critical system. Actually, if you have problems on the beamline, this really costs us money, for example. So if the beamline cannot, or something is not available on the beamline or the control room, we really have a problem. Okay, some slides about the build environment. So we build the modules on dedicated systems. So actually, there's just virtual systems with a defined set of RPMs. So we are using scientific Linux. So actually, we know our dependencies. We know which system libraries are really used. And modules which we want to optimize, of course, this we have to build on the target system itself. So it's like you. So if you have a special CPU, of course, this must be compiled on the system itself, on the same node with the same CPU. There's no way or no other way to do it. So actually, we also thought about using easy build, but yeah, actually, compiling software is not really a big problem for us. So I know how to handle configure CMake and all this. So actually, easy build is nice, but for us, it doesn't help much or so much. And so actually, I just write a small tool in Bash, actually just a library we can source. And we have something like build scripts for each module we have. And build script actually looks like this. So actually, we have this, I would say, the main advantage of easy build we have reproducible builds. We can version control this, and it's easy. We just can use it. For example, this script can be used. This is OpenMPI. Actually, this script can be used for different MPI versions. The next, here we see usage of it. Actually, I just can call this script build version. I want to build it with a certain GCC. That's it. Okay, some notes about it. Of course, we need the source tarball somewhere. This must be downloaded and must be stored somewhere on AFS. We need a module file somewhere available. The module files are also on the version control. We use Git for it. This call here above really produces a usable module. So it installs everything, and actually you can start using it immediately as it's finished. This I mentioned already. So actually, if we go back, there's nothing like a version mentioned here. So actually, we can use this script for different versions and different combinations if you want to use another compiler or whatever. Sometimes you have to handle some special cases, but these are very seldom. So it happens, but of course, different OS may require some special handling, or a different version may, but usually it really looks like this. Okay, these scripts are in a Git repository. The Git repository is open. Actually, everybody can check it out. Everybody can check how the module is built, how the configure is coded, or the CMake or whatever. The rights to install a module are handled by setting AFS access rights. So we can just define this user is allowed to install modules at a certain place. Actually, everybody can compile it, whatever he wants, but he's not able to install it. This is controlled by AFS ACLs. And yeah, this is actually one of the main advantages I see. We don't have the resources to maintain all modules. And we can now tell users, okay, you are always needing the newest boost root or whatever version. Do it. This helps you, this helps us. Okay, yeah. Just a short note about using EasyBuild. Yeah, we thought about it. Maybe we will use it later, but actually it wasn't, yeah. It's not really something, we have 50, 60 modules, and writing the build scripts ourselves is usually not a really big problem. And the main problem, for example, the last modules I have to build was for Gromax and CPMD, and there are no EasyBuild build blocks available. And the biggest problem to compile is really to get it compiled. If you know how to compile it, writing the build script is a piece of cake. Yeah. So, okay, just last slide. Okay, so everything is compatible to the existing modules. Actually, we still can use existing module system at the same time, no problem. Actually, it's easy to learn for the users. The users do not have to learn much new things. Actually, he has to know that there's some hierarchical structure and there's a module search command. That's it almost. We can provide the modules very easy and very fast. So actually, a couple of weeks ago, somebody drops in, asked me for a new GCC version. Actually, I just start the build script, and okay, we have to wait for GCC a couple of hours, and then it was available. Usually, providing new modules is, as long as we know how to compile, it's very easy. The modules are running on all new Linux distribution, really test. So we really test the modules on Ubuntu 12, on OpenSUSE. We can compile actually the same modules, the same build scripts on Mac OS X. So we have very little overhead to provide the same modules on Mac OS X. We can delegate module maintenance. We can provide something like a local installation. And last but not least, this module lifecycle really helps us to remove old modules. Okay, that's it.